Hello, everyone. Welcome to this session. Let's talk about how we can use AI. Let's see the AI building blocks that we have to build an application in .NET. My name is Bruno. I'm part of the DevRel team at GitHub/Microsoft. And I'm excited to talk about this because we have so many things to talk. I'm not sure if we are going to be able to see everything, but hey, let's give it a try. We have a lot of content to show. And let's start with the final application, with the real application. We have our Java application, which are the content showcase of applications. And here, what we are going to see, let me go back to the app, it's literally a full support application that we have. This is a support center application where we analyze incidents. And this analyze incidents is kind of for a full user who is going to also improve the application and more. And we can see here in the chat that the user can generate images, then can analyze some payment errors, very specific incidents, and we will have some responses of data analysis of the incidents. Then we have, okay, make it in 2 tier, make a deeper analysis. And you know what? When you finish the analysis, display why are you giving me this feedback. So in the last question here in the chat, what we are going to have is we are going to say, okay, this is the feedback of this incident, this payment incident, and it's tied to this information. This is external information. What we just seen here is the standard ABC and more that we have here in an application, because behind this support application, everything is coordinated with Aspire. So we have Aspire here. Let's take a look at the graph that is running 3 services. We have a web UI. This is a Blazor.NET application that is interacting with 2 services. It's interacting with the Microsoft Agent Framework agent that is doing some image generation, data grounded, and more here. And it's also interacting with another agent, and in this scenario is an NVIDIA Nemo agent. NVIDIA has a toolkit. It's called the Nemo Toolkit agent or agent toolkit. And we also created one agent there that is doing the data analysis, and it's all put together. And we have a lot of elements here. We can go to the traces, and we can see in the traces, like every time that we have these scenarios, we have the generated dates for the math interactions. But at the same time, if we go back to the information for the data analysis, we should see here that this also include, even if this is a Nemo agent, we can see also here the generative AI information here. So we put it all together right now, and what we have is we are basically using building blocks, .NET AI building blocks to have this, and let's basically start to deconstruct the magic. Let's start to focus on what we are going to talk in the next 30-35 minutes. We have different layers. I split this in 5. You can do it in more or less if you want to group some of them. But let's start with the foundation. The foundation is Microsoft Extension for AI. Then when we start to talk about data, we probably start to talk about vector data, data ingestion, and more. We talk about tools, and NCP comes here. We talk about agents. We have agent framework. And then we have, in this specific scenario, the connection between 2 agents using agent to agent. But there are other topics, like in example, you can see like when you have AGUI in other sessions and more. And as I said, the first topic to talk is Microsoft Extension for AI. And Microsoft Extension for AI is a chat abstraction, which is provider agnostic. So you can connect, let's start by the beginning, by a chat, but you can connect to chat that runs in the cloud, in example, in Foundry or in other provider that run locally. And the idea is that when you have this interface, which, by the way, is iChat in client interface, you can start to interact with those LLMs. And this is the key part. This is where we start. Another topic here, which is important, is that Microsoft Extension for AI, and depending what library or what backend are you using, in example, if we use Foundry, we are going to have the chance that instead of using the standard endpoint URL, model name, and API key, you can use integrated security, integrated identity, and you can use pass their Enter ID, your Enter ID to authenticate this. By the way, if you're using Foundry, this is the way to go. So let's give it a try and start to see this. In order to take a look at all of this content, what we are going to have is let's going to base our content in 2 main resources. First of all, the official documentations that we have in AI app for .NET developers. This is important because this covers all of the topics that we have: Microsoft Extension for AI, evaluation libraries, data ingestion, and more. And the samples that we are going to use came from the generative AI for beginners in .NET. So it's a mix between real samples. You probably know me. I started with the demo. I love the code. And we also have the foundation documents and most close samples here. So if we start by the beginning, if we start with chat, what we are going to see is that, let's basically open one of the samples that we have here. We are going to use here a file-based application. And this file-based application is using some libraries. Let's zoom this a little. We are using Microsoft Extension for AI, of course, and then Azure AI. I am running these samples against a backend. This is my current Foundry backend, where you can see I have different models. I have a GPT-Maze2 to generate image, GPT-5 Mini, Kimi. I have a Grok model, text embedding. There are a lot of samples here to support this. So going back to the code, I have these libraries, and the main idea here is that I am going to use integrated security, so I don't need to pass an API key, and the endpoint and the model will come from some user secrets that this application is using. So by default, I think the default values is GPT-5 Mini. And with this, what I'm going to create an Azure client. Once again, we can see the difference here using an name, endpoint, and API key, or in this scenario, I'm going to use a CLI credential because I have my demos running from the console and I already did the AC login to identify myself. Once I have this, these are the 3 lines that make the magic. Create the client and then get an iChat client. That's it. This is as simple as we can start to interact with the chat. The important part here is that later, what we can do is we can pick up the response from the question. I think the first question that we have is, what is your model name? And we can show the question online. So if I run this sample here, I am in the file. Yes, let's do .NET app.cs. We are using GPT-5 here. We are asking, what is your model name? And after a couple of seconds, we are going to have the response saying, hey, I don't have a personal name. I am an AI assistant based in OpenAI GPT family. So that's fine, because usually the models you can probably ask for the model card, but they usually don't give you the name. However, I can go back to my code and let's change the deployment name to use Kimi, 𝗬𝗀𝗀𝗀𝗀 This is the version that we have. And if I run again the sample, I can't remember if Kimi replies with the name, but we are probably going to have a different answer. This is how easy it is to change models. This is how easy it is to change model and say, okay, yes, I am Kimi, an AI assistant developed by Moonshot AI. Remember, both of those samples are running in Azure. And the nice part about our using the chat elements in Microsoft Extension for AI is that you can connect literally to everything that supports that chat interface. How about if we want to run local models? Let me switch to one of my demo environments here. If we want to run local models, I have here running 𝗲𝗲𝗀𝗀𝗀. 𝗲𝗲𝗀 is a provider. You can do this with 𝗲𝗲𝗀, LM Studio, or Foundry Local. Foundry Local is very, very good. In this 𝗲𝗲𝗀 instance, I have several models installed here. I have Nemotron, 5 Mini, Qwen, Llama, another Zema model. So this is all of the models that I have here. And I am going to start a small application that is called 𝗲𝗲𝗀 Monitor that is going to show me in the taskbar here which models are loaded and which models are waiting to be run. And I am going to run one demo, which is going to be very similar to the one that we have, but let's take a look at the code in this one. In this scenario, what we have is where is the 𝗲𝗲𝗀? There it is. What we have, let's close the monitor for a couple of seconds. We are going to create a new 𝗲𝗲𝗀 chat client. This is running locally in the port 11434, and I'm going to use 5 Mini, and I'm going to ask, hey, I'm going to give you some sentences, analyze the sentiment of these sentences, and then give me an overall sentiment average of all of these. And remember, this is all going to work locally. Once I have this, I'm going to get the response, and I'm going to print the response. So let's switch back here to our samples, and let's do samples, core samples, and I think this is the basic 3. Once I am here, I am going to, let's launch here the 𝗲𝗲𝗀 Monitor, so we can see that it's running, but we don't have any model loaded, and let's run this. This is the first time that we run this in a while, so 𝗲𝗲𝗀 doesn't have the model loaded in memory. It's going to take some time. Same, very similar happen if you're using Foundry Locker, an example, and after there it is, the model is loaded, 5 mini, and after a couple of seconds, when the model is loaded, 𝗲𝗲 is going to start the answer, and we are going to start to see what we have. But remember, we have here the full analysis of the sentences. It's the same interface, the same procedure to work with local models, Foundry Local, 𝗲𝗲 in example, with cloud models, with your provider, the one that you want to use, with Foundry, where you can use endpoint, model name, and API key, or you can use endpoint, model name, and integrated security. Again, this is what we suggest, and it's very, very good, very, very easy to use. So we see here, like, basically the foundation, which is working with the chat, how well it works. If we move forward, let me minimize this small machine. If we move forward, we've seen that, hey, this is a stack that we have. And again, this is kind of LLMs, GenAI 101 working with the chat, and we have it there. However, the next step usually is, okay, I want to work with data. We all know that the model has constraints. They don't have access to every data that we have. So usually the next step is, okay, I want to do RAG. And RAG seems to be a very complex or simple. Everybody understands RAGs in a different way. For me, it's a pipeline of named steps. And we have in each one of these steps, reader, chunker, enrich, embeddings, and vector, we have different building blocks. In example, the vector data is going to handle storage and similarity search. Data ingestion is read, chunk, enrich, and more. Embeddings are the ones that is going to allow us to basically convert this text to a vector that represents the meaning of embeddings. And you can use embeddings locally with Foundry Locker, an example. You can use embeddings on the cloud. I think I show you how I have a text embedding small, text 3 embedding small from OpenAI. In Foundry, you can use Cohere and more. There are different embeddings models. Locally, if you want to start and test, I suggest you to use one of the Onyx models. The mini LMs are great. And you're going to start to play with this. And the nice part about that is that you can run scenarios like they are doing RAG or can doing vector and data and more locally to learn, and then switch to the cloud to more powerful models. Like an example, a couple of local models that you can use are very small. They are 50 megabytes, 80 megabytes, and they're great. You can put your text and they are going to generate an embedding. However, if you want to have embeddings that are multilingual, because remember, embedding is going to create a vector where you are going to have the meaning of the text. So you can later query based on meaning. But you can do the query also using another language. So those moments, probably the models on the clouds are going to be better for those scenarios. But once again, let's give it a look at how this works. So let me close here and let's switch to the next block. One important topic that you are going to see here in the resources is that everything that we've seen is represented here in specific lessons on the net and AI. So in example before, we see that this is the homepage for AI apps for .NET developers. And this is the moment that we can see the official documentation talking about extensions, AI library. You have a quick start where you can build an AI application using OpenAI or Azure OpenAI to chat with .NET. And if we move forward, and this is where we are right now, we can see, hey, this is the concept of embedding. So even if you want to learn more later, you can always go back to the Net AI documentations and take a look at these concepts. And here we have, of course, tutorials, and we have step-by-step, and we have more libraries. There are many, many things that you can do. But let's go back to the samples. Let's close this one, and let's go to the basic element that we have here. So what we have here in the core samples is one RAG scenario, and you can see there are many, many samples, one RAG scenario that is doing the following steps. So, of course, start with using these libraries and getting endpoints. I am going to use the embeddings deployment from the cloud. So I am going to use a large language model from the cloud, and I'm going to use also an embedding deployment from the cloud. Let me double check which one do I have. And in Foundry, we have this text embedding 3 small. Yes, it's the small one from OpenAI. Going back to the code, I already did my AC login, so I am ready here, and I am going to create an embedding generator. This is the next step. This is what we need to do. And then on top of that, we are going to create an in-memory data store, in-memory vector store, where we are going to store information. For this specific scenario, our sample is going to be focused on store movies, and we are going to create a store collection just in case for demo purposes, the collection is going to be deleted and ensure to be is going to be created again. And then we have a small supporter here that is going to give us a fake. I think it's 5 or 10 movies that we are going to work, and each one of these movies is going to be created as first is going to be created as a record that is going to have a key, then a title, a description, and the embedding. And the embedding is going to be based on the description of the movie. And this is what we are going to use later to make the search using these libraries. And the important part here is that once we have this in the movie, and we see that for each one of the elements we are going to insert here, we are going to run 2 questions here. Okay, first one is going to be, hey, give me a family-friendly movie that includes ogres and dragons and more. And the second one is going to give me a movie that is going to a hacker who discovers reality is a simulation and more. You probably see where this is going. The important part here is that for each one of these queries, is one of these questions, we are going to create from the string an embedding, and then we are going to do a search. And the search is something that comes out of the box in the extension service that we have. And this is the moment that we are going to have some vector-to-vector cosine. They are going to apply some algorithm to find which one of the vector is closest to the query that we ask. And the important part is that the response will be, hey, this is the movie that is closest there, but also we are going to have a score. And the score is going to represent how close is this. So in example, we are going to ask a question, and the first answer will say, okay, this is movie A, and the score is 98. 98 is very good. In 0 to 100, this is amazing. So it's probably a good result. And the second is going to be, okay, and this is movie B, and the score is 40. So maybe that's not a good one. And remember, here it's all depends on how well we build our pipeline to do the data ingestions, to do the queries and more, but we have all of the elements here. If you are wondering how this is represented, this is the record of the movie where we have a key. In this case, it's going to be a string, depending on what are you needing to use here. And then we have the title and descriptions, also a string. And at the end, we have the embedding, which is going to be a vector store vector that we are going to have here. And we are going to use cosine similarity for the distance function to do the queries. The important part of this demo is that it's going to start as an in-memory sample to search the information, but we can easily switch this to use 𝗏𝗲𝗏 or any vector database that we need to do this. So let's take a look and let's run this. So we are in core samples rag simple O2. Let's go here, let's go up and do rag simple O2. Let's clear this and let me refresh. I think this is, yes, this is a standard. This is a C# project. So let's do a .NET build first, and then let's do a .NET run. And .NET run. So remember, the first step is going to create the list of movies, and we have here the movies, popular movies, as you've probably seen. And the first question is going to be, show me a family-friendly movie that includes ogres and dragons. And yes, we have Shrek here, and we have 494, almost 5, 50% of chances here. And we also have The Lion King. We probably need to work better in the description of these movies to get it closer. And the second question is, show me a movie about a hacker who discovered reality in a simulation. And yes, The Matrix is the first result. But we also have Inception, because probably in the description of Inception, we talk about simulations and reality and more. So there are relationships here. Everything that we show here shows 2 results, because if we go back to our code, we are going to see that we ask for 2 results here, and we show each one of them. Our steps as developers, once we understand these libraries and these building blocks, is to later start to play with them to figure out the best way to work with this. Maybe I only want to have 5 and then do another re-rank of the results. There are hybrid search strategies. All of the libraries are here to basically work with this. And how about if we want to do the data ingestion? This was a very, very simple one. We literally pick up some strings and put it there in the vector store. But there are more complex scenarios. Like an example, let me open the data injection sample. Data ingestion simple one. So in this scenario, what we have is, again, we read the chat model, embeddings, and models and more. We create a logger. We create our clients using the CLI credentials, no keys. Don't use keys if you're using in Foundry. Go always for default Azure credentials, CLI credentials, or whatever fits better with your scenario. And then we are going to do the steps. Remember the steps: breathe, chunk, and more. So the first step, we are going to create a markdown reader. The markdown reader, very obviously, what it's going to do is read markdown, and then we are going to split those documents. They may be big, into chunks, so all of the content stay together. And this is important. This is one of the strategies that we need to follow here. And remember, we are going to use in this scenario a pipeline, the ingestion pipeline, that is going to be the markdown reader first. Then we are going to have a semantic similarity chunker. We're going to have the summary enricher and the vector store writer. All of these using a SQLite vector store to basically run this. So this is kind of a closer approach of something that you are going to run in a real application. So we define here the size of the tokens, the max token that we want to do, and then we create the semantic similarity chunker. The next step is enrich. Of course, we are going to have a short AI summary for each chunk to basically have a better retrieval quality. We want to have something that it's really represents what we have there. And then we are going to do the write. And this is the moment that we are going to have a connection string to the vector store. Remember, this is only local store. And once we have this, similar to what we did before, we are going to have the collection, which is the vector store collection, and we're going to do delete and ensure collection exists async. This is just for demo purposes. You probably don't need to do the delete every time. Once we have this, we have the chunk writer here to write this, and we are going to create the pipeline. This is what I really like, that you have all of the steps here: reader, chunker, writer, logger, factory, because we want to have logs here. And then for each one of the documents that we have here, we are going to create and proceed with this. Final step is how we do the search. So this is a Q&A scenario where we are going to ask questions, and based on what we have, what we ask, we have the query from the user that we create an embedding, we are going to do a search showing 3 to have all of this. So this is all how it works. And as you can see, we start with a very simple scenario. We start with a very simple, just storing a string that represents movies, to something that is much more complex, because we can pick up markdowns or PDF or any type of information that you want, and follow the steps, follow all of the necessary steps that we have here to do the vector data and data injections, which is reader, chunker, enrich, embeddings, and vector store. So if we do a recap right now of where we are, we talk about chat, we talk about embeddings, we talk about vector data, we talk about data ingestion. And at this moment, this is probably when we start to evolve with this scenario, we start to get out of, let's get out of Microsoft attention for AI. Let's talk about tools, because this is the moment that we probably need to talk about internal tools or MCP. And MCP is a wire protocol, it's a standard wire protocol created by Anthropic a couple of years ago. Everybody's on MCP right now. And for me, MCP is the way that we have today to connect external tools. You can do internal because you can run MCP locally for local servers, but external tools with our applications. And the important part here is that we have a first-class SDK in C# to work with Microsoft Extension AI and MCP, and it's amazing. It's maintained by very amazing people here. Also, you can connect literally any public MCP that is around using this SDK. Today, I'm going to do a demo using the Microsoft Learn MCP server. If you want, you can go to the MCP registry that we have in GitHub and see a list of MCP tools that we have there, where you are going to find the Playwright MCP, super popular if you want to do automations, or the GitHub MCP and more. And for this demo, what we are going to do, we are going to create a console application that is going to use a chat client using MCP tools. The MCP is going to be connected to the Microsoft Learn MCP server, which provide access to the latest documentation that is published in Microsoft Learn. And we are going to ask a question 2 times. I think the question is, give me the latest version of, can't remember, of Microsoft Agent Framework and the URL to get this. The model will probably don't know where it works, where it lives, but the second one, when it's connected to the MCP, will have the answer for that. So let's switch quickly to the MCP and start to take a look at the samples here. So if I go here to core samples, and of course the name for this one is MCP Microsoft Learn, like this. This is the MCP server. It's located in learn.microsoft.com/API/MCP. And we are going to ask the same question twice, without MCP and with MCP. But what is important, what is really, really useful, is to take a look at the code here. This is the question that we are going to use. Of course, what is the latest version of Microsoft Agent Framework for C#? Answer with the version number and the link of the official documentation. This is the system prompt, your .NET documentation assistant. This is what the chat client is going to use and more. And then we create the chat client. But the important part here is that we have the endpoint, we have the CLI credential, we have the deployment name, but we add function invocations. Why we add function invocation? Why we have this? Because at this moment, this is part of Microsoft Attention AI, this chat client will be able to invoke external tools. In this case, the tool is going to be an MCP. There are different ways to do this, so bear with me. I am going to show you one, but if you take a look at the documentation, you can put all of the tools. When you create a chat client, you can use the tools on every call. As I said, there are different ways to do this. So the first scenario will be, okay, let's create a list of messages, and for each one of the messages, we are going to display the answer. And we have the system prompt and the question. And the question is, what is the latest version? And this is also important. I haven't mentioned this before. The chat client in Microsoft Attention for AI support literally different ways to work. Right now, there are chat completion, responses, and more. And on the client side, when you ask a question to a model, you can wait until the models give you the response, or you can stream if the model supports streaming token by token, you can stream that question. And this is very important if we want to have a nice user experience, because streaming token by token give the user the sense that, oh, this is working. I like it. I can really, really see what is going in real time. This is what you see in your standard GPT or chat application that you have with AI right now. Going back here, what we have is that in the first scenario, we are going to ask the question to the chat client, and we are going to show the answer. And in the second scenario, what we are going to do, we are going to create an HTTP client transport first. This is part of the MCP SDK, where we are going to define where is our HTTP server. And this Microsoft Learn HTTP doesn't require authentication, anything else. If you are working, for example, with the GitHub MCP server or with the Hugging Face MCP server, you will need to also add all of the necessary auth features or tokens or everything that you need to do to make it work. This is a simple one for demo purposes, but you can take a look at other samples that we have here, in example with Hugging Face. Once we have this, we are going to create an MCP client. And again, there are different ways that you can do this. Take a look at the documentation. This is one that I think is good enough to read. So we are going to create a client that is going to use the client transport that represents the Microsoft Learn MCP. Then we are going to ask the tools. What are the tools that are supported by this MCP server? And we are going to show the list of the tools. And then we are going to ask again the question, literally the same, but this is the main important difference that we have here. Once we are asking the question, we are going to add a new chat options element to the question, and we are going to pass the collection of tools that the MCP provides. And as I said, there are different ways that you can do this. You can pass one tools, all of the tools here in each one of the calls. You can add the tools when you create your chat client. They can be there. You can filter the tools. One important topic here is that if you want to pass all of the tools and there you have MCP clients with thousands of tools that's going to use a lot of context here, you maybe want to do a filter first, figuring out which are the tools that you need and really want to use here. So this is the moment that the library, the building blocks, provides a lot of flexibility to support the creation of application. If we run this model, if we go back here to the code, and this is MCP3, so let's go back here. So let's do MCP 1, 2, 3, clear. Let me double check. This is a program file, so let's do again a .NET build first and do a .NET run. We are going to let's clear and .NET run. Oh, not readme, run. We are going to see that first is going to try to answer the question about the latest version of Microsoft Agent Framework, and the model, I think I'm using the standard GPT-5 mini that I use for most of the demos, is going to try to answer the question. Take some time, but we can see here the token by token output format for everything. So we see here that I don't have live access to external documentation from here, so I can't fetch the current latest NuGet version. So this is the before section where we don't have any answer from the model because it's not connected. In the second one, after, it's going to say, yes, we are connected to the Microsoft Learn MCP server. We have these tools, Microsoft Doc Search, that is doing all of this. We have patterns and more. And on the question, somewhere here, uses pattern, more, asking the model. And, oh, we don't have a single GA version yet, but we have the Microsoft Agent Framework.NET packages, Microsoft Agent AI, and more. And they are published here. And you can take a look here to the Microsoft Framework overview. If we take a look here, let's click this one. Oh, it's opened here. We can see that it gives us access here to the Agent Framework, and somehow we didn't get the version. The version is somewhere there. It's tested, and it's also GA, Microsoft Agent Framework. But hey, this is how the MCP's tools work. We are providing the agent in these steps access to information using data and more, and we are providing the agents also access to external tools that can be, in example, like MCPs. And as I said, there are so many tools that we can use. So wrapping up a little before moving to the next one, we have extensions with chats, embeddings, data, and more. We have tools, and it's all come together right now when we start to talk about agents. And remember, agents, a fast way to describe an agent can be an LLM, choose the one that you really like it, that use a set of system instructions to define how the agent is going to behave, and then use tools to provide the agent features like, an example, memory or access to third-party services that we just seen with the Microsoft Learn MCP and more. And with all of this, we can go from a very simple agent to a more complex one. The important part is that when we start to talk about the agent, we also bring to the table other topics like, an example, workflows, connections to external agents. As we say, agent to agent is a protocol, the one that we used before to connect an EMO agent from NVIDIA with the Microsoft Agent Framework. We can also talk about durable functions, durable workflows, and more. There are so many things. So let's take a look at this and let's see how we can implement this. Going back to the code, and before we forgot and before we move forward, remember, each one of these sections, we are right now in MCP, have in the .NET and AI documentation, you have the getting started with MCP, you have how you can create a minimal client. Important, and I almost forgot about this. I show a sample how we can consume an MCP, but you can create your own servers, and you can expose your resources, tools, and more with MCP. This is also part of the documentation, so it's also going to be all here. So going back to our Microsoft Agent Framework demo, what we are going to see, let's open the hello world of the demo. So here, let's switch to Microsoft Agent Framework samples, and let's open the 01. And this is how we are going to work. So we create a chat client. And once we have the chat client, and this is important, right now, Microsoft Agent Framework provides on top of the chat client a new interface, which is the iAgent, and we are going to have the chat client here, and then we are going to say, hey, chat client, create a new agent. And the minimal agent definition will require a name and a description and instructions. And we have here, the name is going to be a writer that is going to write a story that they are engaging and created. And that's it. That's the minimal expression of an agent, which is kind of a wrapper. When you do this, it's just a wrapper on top of the chat client. But it makes sense because we are going to see here the same exact pattern and capabilities that we have before. So we are going to have this streaming async, and this is a writer. And the writer is going to write a short story about the haunted house with a character named Lucia. So if I go back here to, we are in core samples, let's do math, and let's do math 01. Oh my God, we have so many samples here. So math 01, let me see if this is a, oh, this is a program. So .NET build, let's build this first. And let's run this, .NET run. And what we are going to see here is, once again, using integrated security, or if you want, you can even do this using Foundry local with the local model, your 5.4 mini model locally, and you have your agent locally running here. But this is going to take some time, so in the sense that, hey, we start to see here the token by token, the generation of a story that Lucia has not meant. This is running with an agent. However, agents allows us to put it all together. If we move to another sample, let's take a look at the MCP sample. So we have here agents MCP01, and we take a look at this. We should see here that we create an agent. We have literally the same pieces of code to work with MCPs, and this applies also to functions and more. And then when we have the tools, we are going to provide the tools here. We are going to describe and list the tools that we have here, and we are going to create an agent. And in this agent, on the definition, on the creation of the agent, we are going to add the tools. So this is the part where we are going to have the agent that is going to use the tools. And let's ask the same questions, agent framework for C#, and also once we have this, show this in the streaming async. So let's switch to the MCP01. This is math MCP01. Let's do a clear, and let's do a .NET run directly to run this in one shot. There it is. This one was fast because the first step is to connect to the doc search and show basically the tool that we have here, which is Microsoft Doc Search. And at the bottom, we are going to ask the agent, and we are going to start to get the information. So we can see here how small steps here are performing. When we have external tool in the agent, it was very fast. We have the description of the tool and more. And then we have here the agent information. And we can see here, hey, we have the version here. We have the learn app configuration, how to agent config. So this scenario is working with us and is giving us the version. And I think it's mostly because the system prompt in this one is better than the previous one. So we have an agent answering the question. And we can do more because, as you remember, we can start to talk about different agents. How about if we have two agents? I have here math1 and I have here math2. How about if we have two agents here? I can have the same chat client is going to provide access to the LLM that is going to create first a writer agent and then an editor agent. And this is important. Microsoft Agent Framework will provide later different ways to start to build this agent orchestration. You can manually call an agent, process the output, provide the output to the next agent, process the output and more. And Microsoft Agent Framework also provides some patterns, workflow patterns, like in example, the sequential, call one to the another, another one which are based on round robin scenarios where you can call one to the other, all at the same time. There are different patterns that you can use there, but this is the key lines of code. You can create a workflow. This is the moment that we start to talk about workflows, and then you can add your agents or your nodes or more. There are so many ways that you can do this. So if we use this, we should see that you have agent 1 calling agent 2, and at this moment, we can run this workflow as an agent because internally the workflow is an agent, and we can run this using streaming async. If we're also using this in a web application, there is a super cool tool which is called DevUI that allows you to literally see in real time how the agents are working in a visual interface. You can test your workflows there, you can test your agents there, you can have traces, tool calls, and more in a very nice UI application, which is very, very cool. But this is how easy it is to work with agents. So if we go back here, this is an example, going back to the first scenario, when we have this Java application, we have two agents. Maybe the approach there is something like this. Maybe we have an agent that is involved and it's basically using A2A for this. And one of the A2A agents is a Microsoft Agent Framework, and the other is this NVIDIA agent, so we can make it work all together. Once again, we have the building blocks to do this. If we take a look here at the samples, another sample that we have here is the A2A agent. Let's close this. And what we have is we have a writer agent that is going to live in a URL, in a local URL that we are going to run. And then we are going to create the second agent that is going to be running the second one. To map the A2A, we need to have access to what is called the agent card, which is, I think, ./well-know and card.json. It's basically the description of how the agents work, and you can see that in real time to say, oh, that's my agent. This is how it's working. Going back to the first scenario, I think somewhere here in the internal application, we have this is the Nemo one. And if I go back here to the resources and I take a look at the Nemo URL, oh, we don't have here, but it's slash, oh, where is this? Well known, and you have information from the agent here. We can take a look at the code here for that one, for this one later. But here we can see how both agents working in two URLs are talking. So we have the server with the A2A agent-to-agent server with the agent-to-agent agent that is going to be consumed for the A2A client. By the way, A2A was initially created and opened by Google. And as far as I remember right now, it's part of a Linux Foundation. So everybody's doing this. And I think it's a very, very nice way to run and connect agents from different versions. If we go back to Foundry here, we should see that in the tools option that we have in any Foundry scenario, in any Foundry project, we have the chance to go to custom scenarios and add an A2A agent. And this is the moment where you can provide the name, and then you have the endpoint, and this is what I can't remember the URL, which is /wellknown-agent-card.json that describe this. Of course, here you also have the chance to see how you're going to authenticate with your agent. All of the same, you can do it with Microsoft, with the libraries that we have here for .NET. So we have here the sample, and hey, we have one client talking to the other and then creating this. But we also talk about image generation, how we can plug together everything to have an image generation. So again, this is all part of the building blocks, and we are covering just a small piece here of everything that we have. So if we go back here to the last scenario demo that we have, which is math image generation, where is my image generation with Foundry? What we see here is that first, we are using a library, which is text-to-image image generation, that is going to work with the GPT-Image2 models on the cloud, that requires an endpoint, API key, another sample how we can do this, and a client. And then we are going to have, and this is the important part, we are going to have here a task that is going to generate the image that have a couple of descriptions, and this is the generate image, that is going to be added later as a tool. So we are going to create an agent here. And in this scenario, we have the name and instructions, and we are going to create a tool to do this. So when we ask the agent to create an image, it's going to come here and it's going to talk to these tools. So everything is coming together to see this, and you can test this and see this, and it's going to create an image if you have deployed them. So wrapping up, we are at the end of the session. We talk about agents, MCPs, Microsoft Attention for AI. There are so many things. And by the way, this is all libraries. This is all C# libraries that you can take a look. You can start to use hair images, chat answers, everything that we've seen in the previous application. No black boxes there. It's all available for any .NET developer. And there is more, and this is the important part. You can take a look at all of the foundational libraries. Microsoft Agent Framework doesn't stop at single agent. Support AGUI, as I mentioned. Take a look at the other sessions, durable workflows. There are so many other things that you can use right now, and there are so many other building blocks. Go back to the documentation to see what else you have. So this is the end. And remember, the two main links that you need to have right now is the generative AI for beginners.net for the code samples and the official AI.NET documentations. We've only seen extensions AI, C# and Agent Framework. There are so many things. And hey, I hope you enjoyed the session. See you all in the next one. Goodbye.